Hello and welcome to day 2 of the first week of this lecture series. So, in the first class we learnt about various different possible applications and the real life applications of lasers, and I tried to convince you that it's worth learning a little bit about this laser. Um, so, how we are going to do it throughout the course. So, at this point I would like to very quickly tell you about my plans. So, first few lectures we will concentrate on learning the fundamentals of lasers, the unique properties. We mentioned about certain unique properties: coherence, collimated, monochromaticity, high power, and so on. Now, how do they originate? Okay, and little bit in greater detail we will learn about those properties. Then we will go into the laser instrumentations. So, we will talk about the technicalities. So, knowing the principle of laser action, how one can go and make a laser. So, what are the different types of lasers one can make? We will look into those things, and what are the different types of applications of different types of lasers that one can achieve, that we will talk about it. And last 3 weeks or nearly 4 weeks of this course we will concentrate on the application part, where we will go from little bit basic applications to quite advanced level of applications. So, as I said in my first lecture, there will be food for everyone in this course. So, we will try to keep this course as less mathematical as possible. Wherever it is necessary, of course we have to, otherwise we would like to keep it pretty much basic. Now, let's try to look into the basic things about the laser. So, in order to know about laser, first I need to know what is the full form of this term called laser. So, I have laser, I am sure many of you have learnt about at least this full form of laser. For those who do not, let me explain it. So, this laser has a full form as light amplification by stimulated emission of radiation. Now, if I take out this part, I get my laser. Now, if I look into each and every term here, then I have one main thing is light. Oh, it deals with light. Now, let me ask you a question here. Is laser a process or it is a device? So, is it a process or a device? The answer is both. What we have written here, that light amplification by stimulated emission of radiation, this is a process, and this process is called laser process, and the device which brings about this process is also known as a laser. So they are synonymous. So you can use it for the device as well as when you are talking about the process, you call it a laser process. So here again, coming back to this process, we have a term called light, and what kind of light, that also comes out from this particular statement, that is stimulated emission of radiation. So at least I can see that the stimulated emission of radiation, whatever that is, gives rise to some light. What kind of light? This light is amplified. So if I do not know anything, I just want to understand from this acronym what is this process, then it tells me that if I induced a process called stimulated emission by giving some light, then that light is amplified probably many times, many-fold, and this process gives rise to my laser action. Okay. So when I say about stimulated emission of radiation, there is also a term called emission. So in order to understand this laser process or laser action, we have to know what is stimulated emission, and for that matter what is an emission, how emission occurs. Okay. So we need to learn about different physical processes that takes place when light interacts with matter. So if I want to know about laser, I need to okay. So now okay. So now we will talk about detailed laser action. We will explain in detail in a while about the different light matter interactions, learn about absorption, emission, stimulated emission, and then how the stimulated emission yields light which gets amplified to give laser output. Before going into that detail, which is our main aim, we should know a little bit about the history of laser invention. Okay. So by now you know that okay, we need to know about stimulated emission. Okay, then we can go to the laser action. So how this effort of getting something like a laser started, when did it start? Let's have a look at that. Let's have a walk through the history of laser development. So there are two people who without whom nothing of this sort, nothing like laser or anything would be possible at all. They are Max Planck and Albert Einstein. You may not find a very direct relation between Max Planck to the laser discovery immediately, but if you think about the idea of having a transition between two states in an atom or ion or molecule, by a definite amount of energy, discrete amount of energy, which is termed as a quantum. If that idea was not there, if that idea was not given by Max Planck, we would not achieve anything like laser at all. We would not have the idea of stimulated emission. So, the idea of this discrete transitions by absorbing a certain amount of light, certain quanta of light given by Max Planck, helped developing the field of quantum mechanics. Now, this was at the time of 1900. In 5 years from that, Albert Einstein wrote his famous paper on photoelectric effect, which of course led to Nobel Prize for Albert Einstein. And in this photoelectric effect, one thing came out also that this light has a particle nature, which is photon. So, like which in some way it supports the Planck's work. Now, the main idea of something like laser came from a work of Albert Einstein again. In 1917, he first talked about this stimulated emission. We will talk about that in a while. So, what he said that before this quantum mechanics was there, people knew about absorption of light, they knew emission of light without any external perturbation. That means emission spontaneously or spontaneous emission. There is another thing called stimulated emission. So, Einstein talked about this stimulated emission, and this process, if can be amplified, then one can get lasers. So, that 1917, the work done by Einstein in 1917 actually forms the basis of laser development. So, from then people tried to develop a device which could amplify, which could first generate stimulated emission in a controlled way and then amplify and generate that amplified radiation. Now, it was done in 1917 by Albert Einstein, but it took nearly 40 years, 43 years actually to materialize this. So, how did it happen? So, we will soon see that though when we talk about laser, first thing comes to our mind is in optical frequency, things happening in optical frequency. Now, we will learn in a while that getting an amplified output from a stimulated emission process is easier at longer wavelength, but very tough at shorter wavelengths. So, high frequency generation is difficult. So, at optical frequency, getting this amplified stimulated emission was a fairly big challenge. So, the first successful formation of a device which could deliver an amplified radiation born out of stimulated emission was in the microwave frequency range, and this was called at that point of time as microwave amplification of stimulated emission of radiation, or in short it is called measure. So, measure was the first step towards inventing laser, that is at optical frequency. The the person who basically drove this research and became successful was Charles Townes. So, Charles Townes at Columbia University, while working with some of his colleagues Herbert Ziegler and James Gordon, he first got this measure which uses ammonia as the gain medium. We will know what a gain medium is. So, this development of measure at least proved the point that Einstein made in 1917, way back then. Still, there was no realization of this amplified stimulated emission at optical frequency. When Townes was working at Columbia University, at the same time there were a couple of scientists at Lebedev Institute in Moscow, Nikolai Basov and Alexander Prokhorov. They were also trying to develop laser. Now, they were building oscillator, which is very much required, oscillator or resonator, you need it for making a device like laser. So, they were also working at that point of time, and we will see that these two people, Basov and Prokhorov, they also got the Nobel Prize, shared the Nobel Prize with Townes. Now, there are many other people who were working in the field of measure and trying to develop laser. One of them was Nicholas Bloembergen, who actually worked on one of the finest applications of laser, that is nonlinear optics, and obtained Nobel Prize later on. So, all these names that are written and the milestones that they have achieved, one should really appreciate that, okay. And that is my aim, and that is the reason I am putting this brief history, talking about it today. Now, after making this measure, Townes and Swallow wrote a paper in 1958, which is a one of the finest paper that they wrote in Physical Review, the journal Physical Review, where they actually showed that it is possible to convert a measure into a laser, that is so called optical measure. That was the term that was used at that point of time, that optical measure, and Townes and Swallow showed that optical measure is possible. And another person, Gordon Gould, he was also trying to do the same thing, and he chalked out his plan to form this optical measure or laser, and he even gave this beautiful name, laser. He is the guy who used or uttered this term for the first time, that light amplification by stimulated emission of radiation, in 1959 in a conference where he was presenting his paper. And you can see on your screen that a copy of the notebook of Gordon Gould, where he has described how one can actually make this laser. But till then, no luck with a laser. Finally, in 1960, a scientist called Theodor Maiman, who is a physicist, he ultimately got lucky and made the first optical laser. He used a crystal of ruby to get a output in the visible range, that is at 694 nanometer, and got it to laze. And that was the first instance when people saw that yes, laser is actually possible. So he got something called pulsed ruby laser, that is the light does not come out continuously, it comes in pulse. So it comes and off, comes on and off, on and off. So they comes as a train of bunch of photons. So just to show you that what was the first instrument that he used to form this laser, so I have given you two images. One is the image of the ruby laser that he formed on your left side, and on the right bottom you have the components of this laser, and you can get these images in web very easily. I have taken it from Wikipedia, and this is Theodore Maiman. After that, there were a huge effort to build lasers out of different materials. So there are certain criteria that a material should satisfy in order to be able to work as a laser or produce a lasering action. So one of them was Peter Sorokin, who demonstrated in the same year when Maiman first materialized this ruby laser, that uranium can be used to form a laser. And the first gas laser, remember ruby is a solid crystal, and the first gas laser came into the picture in the form of helium neon laser by Javan, Bennett and Heriot in the year 1960. And one more important thing is that this helium neon laser, which is very often called HENI in short, gives a continuous beam of light as opposed to the ruby laser that Maiman invented, which was pulsed in nature. All right. So let's keep going. So there are several other works done by different people. Some of them I have mentioned in the slides. So here comes, right after 1 year of its invention, this ruby laser was applied in the treatment of retinal tumor. To destroy a retinal tumor, ruby laser was used. Now, interesting thing is, when laser was invented, nobody was sure what they can do with laser. So they were clueless, they were just trying to make it. But after its invention, actually turns out that you can apply it to various different places, and this is the first example where laser was used in medical science, where they used for destroy retinal tumor using ruby laser. Then there are several other techniques came into the picture. For example, something called Q switching, we will learn about it, and mode locking. So these techniques did become available. People were working hard to develop a better laser, different types of lasers. And one of the lasers that finds a wide applicability is yttrium aluminum garnet, or in short YAG laser. So this YAG laser were first made in 1962 in the Bell Labs. Ultrafast lasers found its a boost when this mode locking technique was built, and carbon dioxide laser was invented by Kumar Patel in 1964, which is one of the most important laser for industrial applications. I talked about this, cutting, welding, pinning, cladding, everything is basically done using carbon dioxide laser because it gives a huge power. ND arc laser came into the picture in 1964, and laser mode locking and phase locking was done in 1965. Several Nobel Prize were awarded to the physicists who have been working toward this laser development. Charles Cow was one of them, who received Nobel Prize in 2009. Now first dye laser, which is a solution phase gain medium, was developed by Sorokin and Lankard in 1966. We will talk about dye laser quite a bit. There are other kinds of laser, for example, excimer laser was invented in 1970, and in this way several different other lasers have been built so far, and the field of laser technology is quite advanced nowadays. So I hope I could tell you about the brief history of the laser development. So in the next class we will start looking at the principles of laser action. Thank you very much.